let's do some problems on the logarithms and working with logarithms. So for example, part A here is we have to rewrite this product. So what we will do is we're gonna take this product and apply the property of logarithms, which is log of x times y equals log x plus log y. So we'll have we'll write this as a product, so 3 times x squared times 1 over y, in which case this translates to log of 3 plus log of x squared plus log of 1 over y. Now we will use the property of logarithms that the exponents come out come out of the logarithm. So this is going to be log 3 plus, this is the exponent that comes out of the logarithm, so 2 times log of x, and here the exponent in 1 over y is, the exponent is negative 1, so it's negative 1 that comes out, and we have minus log of y, and that's the final answer. In the next problem, the radical is going to be an exponent of 1/3. So I'll rewrite this as an exponent. I'll have x over y squared times 2 to the x, all raised to 1/3. That's how I rewrite the cube root. It's the exponent of 1/3. And then I use the property of logarithms that this comes out. So I'll have this is 1/3 log base 2 of, and I copy the base here, so x over y squared times 2 to the x. Then I use the property that logarithm turns products into sums and quotients into differences, so I'll have 1/3 that multiplies log base 2 of x minus log base 2 of y squared plus log base 2 of 2 to the x. Now I'll work, so I have minus here because y squared was in the denominator. And now I'll work on each of these three pieces separately. There's nothing I can do with log base 2 of x. I leave that one as it is. So log base 2x. The next one, I can take this exponent of y squared and take it out, so minus 2 log base 2 of y. And for the last one, I see that log base 2 and 2 to the x are inverse functions of each other, so they cancel each other out, and what I'm left with is plus x. And that's the final answer. Okay, so for the next one, I do the same. So first of all, this is a product of two things. So this is going to be ln e to the 3x plus ln of cube root of x. Ln of e to the 3x is composition of logarithm, natural log, and the exponential. So they cancel each other out because they are inverse functions of each other. I'm left with only 3x. I will rewrite the cube root as exponent of 1/3, so I'll have plus ln x to the 1/3, and I use the property of logarithms that this comes out in front of the logarithm. So this is going to be 3x plus 1/3 ln x. Okay. Next problem is asking to do the opposite. So here we have some constants in front of the logarithm. They will come in the logarithm as exponents. So when I want to rewrite this, I'll have log of x squared, and then I'll have plus log of y to the negative 3, and plus log of z to the 4th power. So this is going to be just a log of x squared, y to the negative 3, z to the 4. Well, the only other thing I can do is rewrite this y to the negative 3 in the denominator. So this is going to be x squared z to the 4 over y squared. For the next one, there's various ways in which I can achieve this. For example, I can take this and bring it inside the log. So I'll have log of x squared raised to the power of 1/2 minus log x cubed raised to the power of 1/3. And the first one, I have x squared raised to the power of 1/2. That's log of x. And the second one, again, cube and 1/3. When you take power and raise it to another power, you multiply exponents. So you'll have log of x 3 times 1/3, which is just log x. Now we have log x minus log x, and this is 0. So that's the final answer. Final answer is 0. For the next problem, we need to solve some equations involving exponentials and logarithms. Whenever